Coincidences versus probabilities. Although a particular coincidence may be highly unlikely, some similar coincidence may be extremely likely or even certain to occur. In general, this means that coincidences should be expected to occur with their likelihoods dictated by the laws of probability. So here's the idea. A particular coincidence, like naming it very particularly, may not be as likely to happen, but it happening in a general sense is a lot more likely. So here, suppose there's 25 students in your class. What's the probability that at least one person has the same birthday as you? So we are fixing one date, and we're trying to figure out what's the probability that one of the 24 will match that. So this is our at least one, which we saw in the test, which did confuse a lot of y'all. So the way we figure out the probability of at least one is we figure out the probability of none. And we subtract that from one. So the probability of at least one is 1 minus the probability of no matches versus at least one match. Okay. So we have your one, and then the other people can be any birthday as long as it's not yours. So in math, we just always go with 365 for the number of days. So the probability of no match is going to be, for one person, 364 out of 365. They can be any other number they want. And that is for every other person in the class. So that is 24 times. That's our probability for no matches. That is going to be a really, really big number that is still a little bit less than 1. And then we're going to subtract that from 1. So let's crunch some crazy numbers. 364 divided by 365 in parentheses, safe math, wrong buttons. Then our caret key for exponent 24. So 0.9363. That would keep going on, just the calculator here is programmed to stop at a certain point. Yep. And then we're going to do 1 minus 0.9363. So 0.0637. So that is a little over a 6% chance. Because this is the decimal, not the percent. So the chances of, in your class of 25, somebody matching your birthday, very, very little. Now, take a look at B, the slight difference. What's the probability that some pair of students in the class share the same birthday? Now it's a little bit different because it's not your particular day, it's is there one pair, at least one pair that matches? So it's still an at least one problem. So we're going to figure out none. So we have to figure out the probability that there are no matching birthdays. And this is including you as a person again now. So no matching birthdays. The first person hold on, I'm going to pause. So the probability of no matching birthdays. The first person has a choice of whatever birthday they want. So they get a choice of 365 out of 365. But that is just one. So the next person has to be different from that one. So they only have 364 days they can choose out of 365. And then 363 out of 365. 24 times. And then you multiply all of those and you get a number, which I'm going to cheat and dig it out from the book because it is a pain to type. So that ridiculous thing, after it's all multiplied out, comes out to about 0.431. It is 1.348 times 10 to the 61st over 3.126 times 10 to the 61st. Okay, that is ridiculously huge. So 0.431. So that's the probability that nobody's birthday matches. So at least one pair of people matching is 1 minus that, which is actually a lot bigger than what we got on part A. So I have 1 minus 0.431. So 0.569. So almost 57% chance that two people will have the same birthday in a class of 25 students. Crazy, right? Now, if you make the class a little bit bigger, this top number gets smaller, and then this gets even more certain. So there's actually a number where you can almost guarantee it, which is crazy, I know. Well, I mean, obviously if I had 365 people, then for sure there's a pair, but I think it's like 20 something when the probability is like ridiculously low for nobody to match. So it's ridiculously high for at least one pair to match. Because the at least includes like 2 people matching, 3 people matching, like it's a lot of different numbers to count. That is why we do the flip side, none and then 1 minus. All right. So that is all of our 7E stuff. Catch y'all on the flip side.